In this video, I'll be covering question 1, part C from the 2019 AP Calculus AB free response calculator required portion of the exam. I cover A, B, C, and D all in their own separate videos, so if you want to watch any of those other solutions, feel free to check out my other videos. Part C here on this problem wants to know at what time on this given interval is the greatest number of fish in the lake. And so we're looking for the greatest total amount of fish. When you're looking for the greatest of something, that's really going to be an absolute max-min problem. It would be a different problem if we didn't have these bounds. We'd be looking at more of a local max-min setup. But when you have bounds on a problem, you want to be using the absolute max-min process. So the first thing we need to do is come up with an equation that's going to give us our total amount of fish in the lake at any given time. And that's going to be using an integral. An integral gives us the total amount of something. It's an accumulation tool. And what we want to accumulate is the total amount of fish. So what that's going to look like is that would be the integral from time 0 to some time t. And then what you would do is you would say, well, I've got a certain amount that are coming in. So I'm just going to kind of do a little bit of notation here. We'd have the total amount entering the E equation minus how many are leaving. And that's going to give us how many are in the lake at any given amount of time. And so that is our total amount equation. That's what we're trying to find the maximum of here. So from there, let's go ahead and put in the equations now that we have sort of a general form for our integral. So this would be the integral from 0 to t. We have e of t here, so that would be our entering equation. So that's going to be 20 plus 15 sine of pi t over 6, and we want to subtract off of that. And when you subtract something, remember you're subtracting that full equation, so you want to make sure you put that in parentheses. So then we're going to use our leaving equation, 4 plus 2 raised to the 0.1 t squared, and then dt. So once you've got your equation, step 1 of your absolute max process would be to go ahead and find the derivative. And so here's where we're running into that fundamental theorem of calculus part 1, where we've got a variable sitting up inside our integral here. And what we need to do is we want to take the derivative of both sides of this. So we're going to ddt both sides of this equation. And what that does is on the left side here, we end up with a prime of t. And on the right side, that fundamental theorem of calculus says really derivatives just cancel out antiderivatives. So that variable just drops straight into our equation. So our a prime of t is going to equal 20 plus 15 sine of pi t over 6 minus parentheses 4 plus 2.1 to the t squared. So that is our derivative right there using that fundamental theorem of calculus, part 1. And then we come back in and we say, okay, well, step 2 of the absolute max-min process is we need to find our critical values. So critical values occur when your derivative equals 0 or when your derivative is undefined. And that undefined one is usually when you've got fractions and you have to worry about division by 0. So we're actually not going to have to concern ourselves with that piece. We're only going to want to find that critical value where this is equal to 0. So we'll come back in and we'll set this equation equal to 0. And we want to find where that's happening at. Minus parentheses 4 plus 2 raised to the 0.1 t squared. Again, lucky for us, even though that's a crazy equation, we are in a calculator required portion. So to find out where that's happening, we're going to use our calculator. And what we'll do here, this is what I just sort of refer to as a something equals something. Whenever you've got a problem where you've got one something set equal to another, you can do this in the calculator pretty quick and easy. You'll take that first something, put that into y1. We'll take our second something, we'll put that into y2, and then from there we'll graph this and do a second calc, and then we're going to choose the number 5 option in the menu, which is intersect. The place where any two graphs are equal or where they run into each other because they share a common point, and conveniently our calculator will calc that out for us, no problem. So let's go ahead and open up our calculator. We'll go into our y equals in the top left corner, and we'll type in our first equation. So 20 plus 15 sine of pi, and then whatever you're graphing something, if they call it t, whatever they call the variable in the equation, when we're graphing, we always just call that x. So we type in x minus parentheses 4 plus 2 raised to the 0.1, and again, x instead of t squared. And then in y2, we're going to put 0. We'll graph those. And what we can see, remember that even though I see a couple of intersects happening over here, that this problem only works between 0 and 8. So the only intersect we're concerned with is going to be the intersect on that right-hand side there, and we'll go calc that one intersect. So to do that, you hit second, then choose the calc menu, the button above trace at the very top, and inside there you're going to choose that number 5 option, which is intersect. It's going to ask you a series of 3 questions at the bottom of the screen. The first 2 we could really care less about. It's going to say, is that the first curve? Yep, that's the first curve. Go ahead and hit enter. It'll switch automatically to the second curve for us and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. And now it's this third question, the guess, that really matters. What you want to do now when it's asking you to guess is you just want to scroll your cursor over to the right so that you're close to the intersect you're trying to find. The calculator is always going to find the intersect that it's closest to when you guess, so just make sure you guess close to the intersect you're looking for, and then you hit enter a third and final time. And out of there, we get this value, 6.203564. When you're doing it, before it's the final answer, usually on an AP Calc test, you want to keep it to 6 decimal places. So 6.203564. 6.203564, yes, 564. So that is our critical value right there. Then after that, step 3 of our process when we're doing absolute max-min, this is what sets it apart from a first derivative test, is we just want to plug in all of our critical values and those endpoints back into the original function. And whichever one has the largest y value out of that group, that's going to be where our absolute max is happening, and that will be telling us where we have the largest amount of fish. So what we do is we're going back to this original equation here. So remember that this is the original equation. So when we come through to do this, we're going to need to do it at 3 different places. We're going to have our endpoints, which will be 0 and 8, and we're going to have our critical values. So we're going to do a of 0, that's our endpoint. Remember, when we're working with these types of problems, this equation up here, this is function notation. Whatever I replace t with here, you replace t with in that equation, no matter if it's up in an integral or not. So we would get out of here the integral from 0 to 0, and we would want to use the version of our problem that has the equation set in. So this would be 20 plus 15 sine of pi t over 6 minus parentheses 4 plus 2 to the 0.1 t squared, and then dt. And we'll end up plugging this into our calculator and getting out a value for that. The good news on this first one, though, is anytime you notice that you've got your bounds are matching, anytime the top bound and the lower bound are the same value, no matter what that value is, the answer is always 0. So this one we can just get out real fast. That's going to be 0. Then we're going to go ahead and we would plug in our other endpoint, which would be 8. So this would be the integral from 0 to 8 of 20 plus 15, the sine of pi t over 6 minus parentheses 4 plus 2 to the 0.1 t squared, and then dt, and we'll get an answer out for that. I'm going to do all of these in the calculator at the same time, so I'm going to set up the last one. So our last one is going to be where we had our critical value. So this would be a of 6.203564. So that's going to equal the integral from 0 to 6.203564, again, of this huge equation here. Sometimes it's just a battle of wills when you're doing math problems, just to make sure you track every little piece that you're going through. And we'll get a value out for that. And from that list, we'll choose the one that has the largest value. Well, again, the benefit to us is that this is a calculator required section. And so what we can do on this is get these out of our calculator real quick and easy. So step one, in Y1, we're going to put that full A of t equation that we got out. From there, we would go ahead and graph that. And then now we're going to go in and we're going to use that calc menu. We'll hit second, calc, and then inside the calc menu, we'll choose the number 7 option, which says integral of f of x dx. We'll do that for 2 of our problems, and we'll end up getting out our values, and we'll compare those. So we open up our calculator, and lucky for us, we have that full equation already typed in because we did that earlier. So here we just need to go ahead and delete out the 0 that's on the bottom. And now we've got our full equation already typed in. We graph it. And now we're going to hit second, calc, and then we'll choose that number 7 option, integral of f of x dx. So I'm doing the 8 one first. So my lower bound is 0. Hit 0 and then enter. It'll ask me for an upper limit on the bottom of the screen now, and I'll go ahead and type in 8. Hit enter. It's going to shade it all in, and at the bottom of the screen, it's going to tell me the integral of f of x dx equals 80.919. Again, like, look that to the long answer, so 80.9199. So that's what 8 would equal. And now we're going to come back in and we're just going to do the same thing with 6.203564. So we do a second calc. Again, integral of f of x dx. It's going to ask us for the lower limit. The lower limit is 0. It'll ask us for that upper limit. We'll type in 6.203564. Hit enter. It doesn't shade it visually for us because it's already got the shade there. And at the bottom of the screen, we're going to see 135.01492. So from that list, we can now clearly see that the largest y value is happening here. That would be when we have the greatest amount of fish. And when did that happen? That happened at this value here. So at t equals, and then you would they always want you to round to 3 decimals at the end of the problem when you're giving them a final answer. So this would be 6.203 is when we have the greatest amount of fish in the lake. And so again, it's an absolute max-min problem. When people want us to find the greatest amount of something, we go ahead and do an absolute max-min process. On this one, we would have ended up with a single point from kind of getting out our critical values, setting this piece up. We would have gotten a single point out for getting our answer correct, which was the 6.203, or I guess that would have been 6.204 if we round that. That would have given us 1 point. And then this justification, this work here of the comparing our values, that would have given us a 3rd point. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.